Hello students, we are about to discuss thermodynamics. Chemical energy stored by molecules can be released as heat during chemical reactions when a fuel like methane, cooking gas or coal burns in air. The chemical energy may also be used to do mechanical work when a fuel burns in an engine or to provide electrical energy through a galvanic cell like dry cell. Thus, various forms of energy are interrelated, and under certain conditions, this may be transformed from one form into another. The study of these energy transformations forms the subject matter of thermodynamics. The laws of thermodynamics deal with energy change of macroscopic systems. So, energy change of macroscopic systems, not microscopic systems. Because macroscopic system contains huge amount of molecules, where microscopic systems only contains a fewer number of molecules. Thermodynamics is not concerned about how and at what rate these transformations of energy are carried out, but is based on initial and final state. So we are interested about initial and final state of a thermodynamic process. Laws of thermodynamics apply only when a system is in equilibrium or moves from one equilibrium to another equilibrium. Macroscopic properties like pressure and temperature do not change with time for a system in equilibrium state. In this unit, we would like to answer some of the important questions through thermodynamics, like how do we determine the energy changes involved in a chemical reaction or process? Will it occur or not? What drives a chemical reaction or process? To what extent do the chemical reaction proceed? So we are now about to discuss what is thermodynamic state. Thermodynamic state. We are interested in chemical reactions and the energy changes accompanying them. In order to quantify these energy changes, we need to separate the system which is under observations from remaining part of the universe. You see, what is system? Suppose in a container we have taken some matter which is under experiment. So this is our matter, part of the universe which is under observation. This is called system. That means it is the portion of the whole universe Rest of the universe is called surroundings. So we may call universe equals to system plus surroundings. So there are three types of systems. We'll discuss now. That means system is of three types. One is open system. Number two is closed system. And number three is isolated system. So what is open system? Suppose in a beaker we have taken some hot water. So in this system, it is called open system because here exchange of matter and exchange of energy both are operating simultaneously. Because after some time, we will observe that the hot water will be converted to cold water. So here is energy exchange and some water will be lost due to vaporization. So matter also exchange. This is called open system. Closed system, if we take a container, closed container made of conductor of heat, then if we put some hot water here, after some time it will be cooled because as the material of the container is conductor of heat, it can transmit heat. So energy exchange is operating here, but not the exchange of matter. So it is called closed system. And isolated system, if we made a container made of non-conductor of heat, and if we put hot water or any liquid, so after some time that there will be no exchange of, you observe that hot water still remains hot, so no energy exchange, energy exchange and matter exchange operating here. So this is called isolated system. Okay, these are three types of systems. Better example of isolated system, approximate example of isolated system is when we put some hot milk or hot tea in a thermoplast, that is comparable to an isolated system. So now we will discuss what is the state of the system. The state of the system. The system must be described in order to make any useful calculations by specifying quantitatively each of the properties such as its pressure, volume, and temperature, as well as the composition of the system. We need to describe the system by specifying it before and after the change. So we have to know the initial pressure, volume, temperature, composition, and either of it. It may be 2 or 3. So we are interested the initial state and final state. Pressure, volume, temperature are called state variables or state functions because they are not dependent on the path of the system, path of the process, but only dependent on the initial state and final state. So these are called state functions.